teens, welcome back to my channel. I am Khushi Arora, your hashtag teenager teacher, and I am back with another part of our NCERT Exemplar Series of Light, Reflection and Refraction. I hope you have checked out the part 1 and part 2 of this series, because in that I have covered all of the MCQ based questions, and I think we have covered 19 MCQ based questions, and today we will be starting with short answer type questions. So please don't forget to check out those videos. I have given the link in the description. And without any further ado, let's get started with today's video. So, the first short answer question, which is the question number 20 according to our NCERT Exemplar book, says us identify the device used as a spherical mirror or lens in following cases when the image formed is virtual and erect in each case. So they've already given us this information that the image formed will always be virtual and erect in all of the cases. So we just have to identify which type of spherical mirror or lens they have used to obtain that image. Okay, so let's come to option A. It says object is placed between device and its focus, image formed is enlarged and behind it. So if we just remember the cases of mirrors and lenses on a broader scale, if you just remember that the virtual images which are formed by the convex lens and the concave lens, the virtual images were always on the same side as that of the object, and you can also see it over here, right? So lenses part we can just eliminate, and let's get back to mirrors. So here they have told us that the image formed is enlarged, and the convex mirror always makes diminished images. So we can just eliminate that also. And what are we left with? The concave mirror. And which case was it? The sixth case, or the last case that we obtained, gave us an enlarged image which was formed virtual and erect behind the mirror. So the answer here would be a concave mirror. I just told you the first step. What do you have to check? That whether it is a lens case or a mirror case. To check that, just see whether the image is formed on the same side as of the device or is it behind it. So here they have given us that it is enlarged and on the same side as that of the object. So what did I tell you? When it is on the same side, it is of the lens. Okay, and here they have already given again that it is an enlarged image. So enlarged image is always formed by the convex lens, right? So here the answer would be a convex lens, and we can also check it. Which case is it? Enlarged, same side, virtual and erect image is the last case again. Okay, so here it would be a convex lens here, right? Now let's move to C part. Object is placed between infinity and device. Image formed is diminished between focus and optical center and on the same side as that of the object. So let's go by the first step. First step is to check whether it is a lens or a mirror. And they have said us that the image formed is on the same side. So same side means a lens, and here they have given us a diminished image is formed. So here the diminished image will be formed by a concave lens and not convex lens, because the virtual image formed by convex lens is always enlarged. So here the answer would be a concave lens. Concave lens. Now let's move to the last part. Object is placed between infinity and device. Image formed is diminished between pole and focus and behind it. So the first step only gives us the answer, concave mirror or convex mirror. It is the convex mirror, because here we are obtaining a diminished virtual erect image and it is behind it. So here it would be a convex mirror, right? Now let's move to 21st question. The 21st question says, why does a ray of light incident on a rectangular glass slab immersed in any medium emerges parallel in itself? Explain using a diagram. So for answering this question, let's remember the diagram of rectangular glass slab. What was it? That the incident ray is parallel to the emergent ray. But why? I told you to remember this important statement, that the extent of bending of ray of light at the opposite parallel faces, which you can see A, B and C and D, which are the air glass interface and glass air interfaces respectively, of the rectangular glass slab is equal and opposite. What does this mean? That the amount by which the light ray will bend at the first interface is equal and opposite to the amount by which it will bend at the C and D interface. So this just implies that 2 times refraction is taking place, and only because of this reason the incident ray and the emergent ray are parallel. So if this question appears in your exam, you just have to draw the diagram, write this statement, and you can just explain the phenomenon taking place. That 2 times refraction takes place as the incident ray enters the glass slab, that is the air glass interface. It occurs refraction, and what happens? It bends towards the normal as it enters from a rarer medium to a denser medium, and there is a refracted ray. Then again refraction takes place as the light ray is going from the glass air interface to outside, and here refraction takes place while the light ray is going from a denser medium to a rarer medium and away from the normal, and this emergent ray is always parallel to the incident ray, and this will give you 3 marks because all of these short answer type questions are of 3 marks. Now let's move forward with question number 22. So question number 22 here says a pencil when dipped in water in a glass tumbler appears to be bent at the interface of air and water. Why? Because refraction is taking place as the light ray is coming from air to water, and they are asking, will the pencil appear to bend to the same extent if instead of water we use liquids like kerosene or turpentine? Support your answer with reason. So this is a quite simple one if you know the concepts. The light ray will not bend with the same extent. Why? Because all of these liquids, turpentine, kerosene, water, or for instance you take any other liquid, all of these are having different refractive indexes, right? And when the refractive index is different, the extent of bending will also be different, right? It's common logic, and we learnt about this in refractive index concept, that when light ray is coming from one medium to another medium, its speed will change, right? So the extent of bending will not be same. Why? Because the light ray is entering from air to a different medium with different refractive indices, and it will bend according to its varying speeds, right? So this was a quite simple one. Now let's quickly move with question number 23. What does it say? How is the refractive index of a medium related to the speed of light? Obtain an expression of refractive index of a medium with respect to another in terms of speed of light increased to medium. So we have already discussed this concept in the previous conceptual videos. So if you have not yet checked out those videos, please do check them out. The link is given in the description, because that is going to help you get a very good grip of this chapter and answer all of these questions with perfection. So the first part of the question is asking, how is the refractive index of a medium related to the speed of light? So this is asking only about one medium and the speed of light. So this is related to the absolute refractive index. And what was the formula of the refractive index of the medium with respect to the speed of light? It was that the speed of light by the speed of light in that medium. Okay, the first case is speed of light in air or vacuum, you can suppose, by the speed of light in that medium gives us the refractive index of that medium with respect to air. Okay, so the first question was this, and you can just explain this. What are these N, C and V, as I have told you. Then the next part says obtain an expression for refractive index of a medium with respect to another in terms of speed of light in these two medium. So you can just relate this with another example. Say suppose this is refractive index of medium 1 with respect to air. Okay, now I am taking with medium 2, and this will also be C by V2. Here it will be V1, the light in that medium, which is 1, and medium 2's speed of light is V2. Now you can just deduce the formula by just dividing these two. What are they saying? We have to find the refractive index of one medium with respect to another medium. So we can just divide this. N1 by N2 would be what? Here if you divide C by V1 by C by V2. What will be this? It will just be the reciprocal, and we will just reciprocate the V2 and V1. What will it give us? V2 by V1. So you can just explain this formula in detail when you are answering this question, and make sure it is point wise. So you have to give 3 points. Okay, the first one you will write N1 is equal to C by V, or you can just write N is equal to C by V, because they are asking just the absolute refractive index and explain the terms in that. Then for the second part you have to give 2 points. In the first part you will be telling about your medium, that there's a medium N1, there's a medium with refractive index N1, and there's a medium with another refractive index N2, and in the third step you will just be dividing it and deducing the formula out. So this was also a quite simple one. Now let's move forward with question number 24. So this is also a quite simple one. Here we just have to find absolute refractive index of diamond by just substituting the values that we are given. So first they have given us this information. Refractive index of diamond with respect to glass is 1.6. Refractive index of diamond with respect to glass is given as 1.6. And what will the formula be? The absolute refractive index of diamond at the top and absolute refractive index of glass at the bottom. So diamonds we don't know until now, so we will just assume it as X by, we know glass refractive index, which is 1.5. They have already given us in the question, and now we can just find the value by just multiplying 1.6 into 1.5 is what? 2.4. So what is the absolute refractive index of glass? It is 2.4. Now let's move forward with 25th question. So the 25th question is asking, a convex lens of focal length 20 centimeters can produce a magnified virtual as well as real image. Is this a correct statement? If yes, where shall the object be placed in each case for obtaining these images? So this is a very simple question. Why? Because we already know a convex lens can form a magnified virtual as well as real images. What were the cases? The last case, which was the case between f1 and the optical center. What kind of an image was formed? It was a virtual and magnified image, right? So first we can explain about magnified virtual image, f1 and the optical center for the first case. Then second one, they are asking a magnified and a real image. So what will this be? It was formed between the 2f1 and the f1. So what are these? The object distances, and the images were formed respectively magnified virtual and magnified real. So this was also a very simple question, and a tip for this question is you can also draw the diagrams associated to this so that the examiner can award you full marks without any doubt. So we have finally completed all of the 25 questions from our NCERT Exemplar book, and in the upcoming videos we will also be completing the long answer type questions and the remaining short answer type questions. So stay tuned for more videos, and if you like this video, give it a big thumbs up, share it with your friends and subscribe to my channel. I will be back very soon with another part of this series. So till then, take care, goodbye.